Okay, so in this one, right, again, we're asked to solve this equation, okay, and we've got a double angle here in terms of cos. Now, with a cos double angle, remember there's 3 different options, okay, but you've got to look at what else we've got here. Because we've got a cos theta in here, I need to get everything in terms of cos. So the best way here is to rewrite, okay, this cos 2 theta, we'll rewrite it using the identity that we've got in terms of just cos. So the cos 2 theta equals 2 cos squared theta minus 1. That's the best one to use. If you use the other one, 1 minus 2 sine squared, well, you'd have a sine squared here and a cos theta involved. So, you know, different functions, it's going to cause problems. Here, they're all causes now, and it makes life easier. So take your time, multiply out by that 3, so that's going to become 6 cos squared theta. Multiply by that 3, it becomes minus 3 cos theta. Rearrange this then, get everything, remember, so it equals 0. So I have 6 cos squared theta minus cos theta, and then 2 minus 3 is minus 1 equals 0. Okay? And then you can notice we've got a quadratic in cos. Okay? So we can have 2 brackets. Alright? And when we have 2 brackets, okay, there's lots of ways of factorizing this. You might have a different way to the way I teach it here, but the way, you know, we often look at it is because it's 6 cos squared theta, we put 6 cos theta in both brackets, and then on the right hand side here, now this technique works all the time, we put like a multiply add thing, and remember when there's a number in front of that cos squared or the x squared, wherever we've got here squared, if it's a 6, you've got to multiply that by the last number here, okay, by the constant at the end. So basically, because it's a 6, I've got to times this constant at the end by 6. So that'll be minus 1 times 6 is minus 6. That's what I need to multiply to. And then it's going to add up to this number in front of cos. And the number in front of cos here is, of course, is minus 1. So we need 2 numbers that multiply to give 6. So let's just think, well, let's just think 2 and 3. Okay, that multiplies to give 6, doesn't it? 2 and 3. Okay, or I could have 6 and 1, couldn't I? 2 and 3 though, 2 and 3 is useful because I can get them to add up to give minus 1, can't I? So, you know, if I put minus 3 and plus 1, and plus 2, sorry, if you think about it, minus 3 plus 2 will add up to give minus 1. And when I multiply them, it multiplies to give minus 6. So that works. So I'm going to put plus 2 here, minus 3 there. And don't forget, with this method, because we did that thing at the start where we times by 6, that constant, we need to sort of pay back now, if you like, and we need to divide by 6, okay, to get it right. And what you'll find is then, each bracket, of course, at the top has got a common factor. Here, it's got a common factor of 2, so we can take that out. 2 times, what is it, 3 cos theta will give me that, and 2 times 1, won't it, will give me 2. Here, there's a common factor of 3, isn't it? So I can take 3 out. 2 cos theta in the bracket minus 1. And then those factors that have come out, 2 times 3 is 6. Divide by 6, they cancel. So 6 on the top, because 2 times 3 is 6, cancels with that 6. And I end up having then these 2 brackets. Of course, it was equal to 0. We were solving it equals to 0, yeah? Okay? And then you just have the 2 results then. So you say, look, you know, you've got this bracket times this bracket equals 0. So one of those brackets has got to equal 0. So you say the first bracket is equal to 0. Or the second bracket is equal to 0. So if you take that 1 over, it's minus 1. And then, of course, you've got to divide by that 3 to get minus a third. Or, in this case, take that minus 1 over, becomes a plus 1. And then divide by that 2, because you times it by 2, take it over, divide by 2, and you get that. Okay? So then, we need to get 2 results then from here, using our calculator. So cos to the minus 1 of minus a third. Let's get my calculator here. Make sure you're in degree mode. And we get out 70.5 degrees. 1 decimal place is sufficient. And then, if I put cos to the minus 1 here of a half, take the cos over, and I get 60 degrees precisely. Okay, so then all you've got to do then is draw your cos graph. Okay, and we'll draw this properly, okay? You know, we'll do a good scale on it. So if I make sure that, say, what should I go for? Every 2 centimeters, say, represents 90 degrees. If you do it properly, then you're likely then not to make mistakes. It's likely to make it easier to see the other angles, okay, by seeing the symmetry a lot better. So we've got 90 here, 180, 270, 360, and of course this will be theta, okay. And then we've got 1 up here, minus 1 down here. That's what cos is between. Now cos 0, okay, is 1. Cos 90 is 0. Use your calculator if you're not sure. Cos 180 is minus 1. Cos 270 is 0. Cos 360 is 1. So when I draw that curve, I might turn the paper around, it make it easier. Which way should I do it? This way, I think. Yeah, sometimes twisting things around, you can see it on the screen there, is a lot easier to actually draw that graph. Okay, so let's look at our results. We've got a half, which would be here, okay, halfway between 0 and 1. So of course the 60 degrees here, and then we've got this angle here. Now by symmetry, if that's 60, of course to get the other result, so we've got theta equals 60, to get the other result, we've got to sort of think about it with 60 going from 0 to 60 here. So if you, symmetry going backwards from 360, then you're going back 60, so you're taking it away from 360. Okay, you always take it away from 360 on the cos graph. And then minus a third, which is down here somewhere. Have we done that right?
No.
What have I done wrong?
I think you just got the wrong number.
Have I got the wrong number there, have I? Ah. Well, I'm not going to redo it. I'm going to change that. I've made a mistake there. That's 109.5, isn't it? Yeah? 109.5. Brilliant. So, I didn't put the negative in by the looks of it on my calculator. So, 109.5. Okay, so I'll have that angle there and this angle here. Okay? And then minus a third. So my theta then will be, in this case, the 109.5, and of course then to get that angle, I've got to take it away from 360, just by looking at the symmetry, yeah? Because it's to get from here down to 109.5, you've gone from 0 across, so you do the same there to get from there to that angle, and going from 360 across. So 360 take away 109.5. So I get my answers then out. 109.5 and 250.5.